Okay, hi, Assalamualaikum. So today we are going to learn, okay, the last topic for SK015, which is Ionic Equilibria. So kita akan banyak jumpa pH, pOH, and so on. So for this topic ada 3 subtopik. Okay, so kita akan tengok yang pertama hari ini, which is 7.1 acid and bases. So for today's lesson, we are going to define what is acid and base according to Arrhenius and also Bronsted-Lowry theory. So kita akan tengok how to identify conjugate acid and conjugate base according to Bronsted-Lowry theory. Lepas tu kita akan tengok what is the relationship between pH and pOH. pH maybe awak pernah dengar sebelum ni. Okay, pOH mungkin tak pernah dengar. Okay, lepas tu kita akan tengok what is strong acid, strong base, weak acid and weak base. Okay, then kita akan calculate pH untuk strong acid and strong base. Okay, so basically we are going to do all these 5. Okay, let's get started. Let's have a look at what is the definition of acid and base according these 3 theory. The first one is Arrhenius. So basically, according to Arrhenius cakap, acid is a base that produce H plus or H3O plus when dissociate in water. So for example, kita ada HCl. Okay, hydrochloric acid. So, in water, dia akan bercerai, dissociate into ion, which is H plus and Cl minus. Okay, so, memandangkan it produce H plus here. So, basically, HCl adalah Arrhenius acid. Okay, why? Because it produce H plus when dissociate in water. Okay. In contrast to base, base is a substance that produce OH minus when dissociate in water. Okay, for example, we have NaO. So in water, dia akan jadi Na plus and OH minus. So since NaOH produce OH minus, so basically NaOH adalah Arrhenius base. Okay, so remember, acid is any substance that produce H plus. Base is any substance that produce OH minus. Okay. Next, we move on to Lewis. Okay, Lewis cakap, acid adalah a species that accept a pair of electron to form a dative bond. Manakala base pula is a species that donate a pair of electron to form a dative bond. Okay, kita tengok contoh. Okay, BF3 and ammonia. So, ingat balik kita belajar chapter 4, kita ada 3 atom berbar. Okay, these 3 atoms are in complete octet. So, what happened? All these 3 will accept electron. So, basically, boron ni, dia akan terima a pair of electron from ammonia. Okay, bukan daripada ammonia, daripada nitrogen. So, disebabkan itu, boron ni, BF3, dia adalah Lewis acid. Ammonia, dia akan jadi Lewis base. Okay, another example of Lewis acid is any cation. Contoh Cu2+, Fe3+, Fe3+, Fe2+, Al3+, and so on. Okay, and other example is incomplete octet. Yang Madam cakap tadilah atom berbar. Okay, so now, another example of Lewis base is anion. Okay, so anion is any negatively charged species. OH minus, Cn minus, CH3COO minus, and many more lah. So, nampak je negative sign lepas ni. So, itu basically a Lewis base. Okay, so next. Another example of Lewis base is any species that have lone pair. Kita kita ada water, ammonia, okay, and so on. So, basically, Lewis acid adalah species that accept electron. Lewis base is a species that donate electron. So itu according to Lewis. Okay, next kita ada Bronsted-Lowry theory. Okay, so kita akan lebih fokus dekat Bronsted-Lowry theory lah. So Bronsted-Lowry ni cakap, before that, Bronsted-Lowry ni dia dua orang tau, dia bukan seorang. Okay, dia dua orang saintis. So mereka cakap, acid is species that donates a proton to another species. Manakala base pula is a species that accept proton to another species. So proton tu apa? So proton tu basically H+. Okay, kita tengok contoh. Cuba tengok NH4 and NH3. Okay, so basically NH4 plus pasangan dia NH3 lah. So cuba tengok before and after. This is before, this is after. Okay, before dia ada H+, before dia ada 4H, after reaction dia ada 3 hydrogen. So basically NH4 dia lose proton ataupun dia donate proton. Okay, so disebabkan itu dia adalah acid. Okay, so proton dia pergi mana? Proton dia tu sebenarnya diambil oleh water. Kenapa diambil oleh water? Cuba you tengok before and after. Before you have H2O, after reaction you has H3O. Maksudnya bilangan hidrogen bertambah. So, basically, H2O ni adalah base. Okay. Kenapa dia base? Sebab dia accept proton. Okay, because it accept proton from another species. Okay, so next. Kita dah tahu NH4 plus is acid, water is our base. So, what is the connection? So, NH4 and NH3 ni, if this is acid, dia punya pasangan adalah conjugate base. Okay, conjugate base. So, water is a base, so pasangan dia adalah conjugate acid. Okay, apa maksud conjugate tu? Conjugate tu maksud dia terbalik. So, cuba you fikir. Okay, kita ambil contoh this one. NH4 nak jadi NH3, dia akan donate proton. Okay, dia akan donate proton. So, basically NH4 adalah acid. So, sebab dia donate proton. Okay, now, kita cuba fikir secara inversely. Now, ammonia, sebab this is a reversible reaction. So, now, cuba fikir, ammonia becomes NH4 plus. Okay, cuba tengok ammonia nak jadi NH4 plus. So, in order for ammonia to become NH plus, ammonia ni akan terima H plus. Baru dia jadi NH plus. So, basically, this is base lah. Kenapa dia base? Sebab NH3 ni, dia terima satu proton untuk jadi NH4+. So, basically, ammonia is a base. Okay, so conjugate base. Itu terms dia lah. Okay, next. Let's do some exercises over here. Let's have a look at example A. Okay, first, macam mana? First, you have to determine the pair first. So, if this is the chlorine, this species has chlorine, so you cari pasangan yang ada chlorine lah. Okay, after that, you gariskan macam yang Madam buat ni. Okay, now, cuba you compare before and after. Before, no hydrogen. After, you have hydrogen. So, basically, ClO- ni accept. Dia accept proton. So, kalau dia accept proton, so basically ClO adalah base lah. Okay, ClO is a base. Kenapa dia base? Sebab dia accept proton to form HOCl. So, pasangan dia ni automatically akan jadi conjugate acid. Okay, so H2O, You dah tak perlu fikir dah. So basically, kalau satu base, pasangan dia acid lah. So kalau acid, pasangannya adalah conjugate base. Okay, pernah satu ketika dahulu ada student tanya, Madam, bukankah water tu nitrat? Okay, now you akan tengok nanti, water is a very special substance. Dia boleh jadi acidic, boleh jadi basic at the same time. So untuk kes ini, cuba tengok. H2O here, then OH minus here. So maksudnya, this H2O, dia lose proton in order to become OH minus. So bila dia lose proton, basically H2O is a base. Sebab dia donate proton to another species. Okay, so let's do more example here. Okay guys, I already gave you the pair. Okay, Madam dah pairkan siap-siap untuk awak. Awak hanya perlu tentukan sama ada HBr, NH3, NH4+, HBr minus ni apa. Okay, so now cuba kita tengok HBr. So HBr, so after that Br minus. So basically HBr lose proton. So kalau lose proton, cuba tengok balik dekat nota tu. Lose tu maksudnya donate lah. Okay, so means that kita punya HBr adalah acid. Okay, so this one akan jadi conjugate base. Okay, tadi kita cakap HBr dia donate proton kan? Okay, dia donate proton pergi mana? Dia donate proton kepada amonia. So amonia dia akan accept proton tu, so dia akan jadi base. So pasangan base adalah conjugate acid. Okay, so kalau dalam exam keluar, this is how you write it down. Ini soalan famous keluar exam. So basically you have to rewrite the equation. Lepas tu gunakan pembaris untuk padankan pasangan yang betul. After that you label which one acid, which one base, conjugate acid, conjugate base. Okay, now let's move on. Okay, so as I told you before, kita akan berfokus pada Bronsted-Lowry theory. So, cuba kita tengok what is strong acid. Okay, strong acid bermaksud it completely dissociate in aqueous solution and produce high concentration of H+. Okay, so basically strong acid adalah acid yang akan bercerai sepenuhnya and produce high concentration of proton. So, for strong acid, degree of dissociation dia adalah 100%. So, contoh penulisan untuk strong acid, cuba you tengok, kita guna this arrow. Okay, kita guna one way arrow. Kenapa one way arrow? Sebab bila HCl sudah bercerai, dia tidak akan bercantum balik untuk menjadi HCl. Dia bukan reversible equation. Okay, so now. So apa beza strong acid dengan weak acid? Kalau strong acid tadi, dia completely dissociate. Kalau weak acid, dia partially dissociate in aqueous solution and produce low concentration of H+. Okay, untuk weak acid, dia punya alpha, degree of dissociation dia less than 100. So, kita tengok cara penulisan untuk weak acid. Okay, so sebenarnya tips dia, bila you nampak je dalam soalan, dia bagi reversible equation. Biasanya reversible ni adalah untuk weak acid ataupun weak base lah. So, cuba kita tengok HCN, dia punya pasangan apa? CN minus kan? Okay, so maksudnya HCN ni, dia adalah acid. Kenapa acid? Sebab dia lose proton. So, ini akan jadi conjugate base. So, proton HCN tu pergi mana? So, dia akan diambil oleh water. So water akan jadi base. So this is conjugate acid. Okay, biasakan diri untuk buat macam tu. Okay, now let's have a look at strong base. Okay, ini ada typo sikit. So, minta betulkan this is strong base. So, strong base is a base that completely dissociate in aqueous solution and produce high concentration of OH minus. Kalau acid, high concentration of H plus. Kalau base, high concentration of OH minus. So, sama seperti acid, untuk strong base, alpha dia 100. So, cuba kita tengok equation for strong acid, strong base. The arrow is again the one-way punya arrow. Irreversible arrow. Okay, maksudnya NaOH ni, bila dia bercerai, dia tidak akan bercantum balik untuk jadi NaO. Okay, we move on to the weak base. So, weak base, again, di sini ada typo. Okay, untuk weak base is partially dissociated in aqueous solution and produce low concentration of OH minus ion. So, sama seperti weak acid, alpha dia tak sampai 100. Maksudnya tak semua bercerai. Okay, kita tengok equation dia. Okay, sama seperti weak acid, bila you nampak macam ni, irreversible arrow. Not irreversible. This is reversible arrow. So, nampak je reversible, basically this is weak acid or weak base. So, untuk kes ini, okay, ammonia, pasangan dia adalah NH4 plus lah. So, ammonia, cuba tengok, dia akan accept proton. So, kalau accept proton, dia adalah base, this is conjugate acid. So, once you dah tahu dua ni, basically this one akan jadi automatic conjugate acid, and this one akan jadi conjugate base. So, basically, you hanya tentukan salah satu spesies saja. Okay? Banyak bercakap pula, madam, kan? Okay, next we move on to pH scale. This one, I believe semua orang dah pernah tengok kan, pH scale dulu. So, pH scale ni show us the acidic and basic properties of a solution. Okay, so now, sebelum ni you pernah tengok pH. Okay, pH is a measure of concentration of H plus or H3O plus ion. H plus dengan H3O plus basically benda yang sama. Okay, so pH ni bagi tahu kita berapa banyak H plus dalam solution awak. So the formula is pH equals to negative log concentration of H plus. Okay, pOH. Okay, pOH bagi tahu kita how much concentration of OH minus in the solution. And the formula is pOH equals to negative log OH minus. So basically that's the formula for pH and pOH. So apa kaitan pH dengan pOH? Okay, let's consider water. Okay, let's consider water. So ionization, for water, for pure water, okay, so dia akan dissociate jadi ion juga. Okay, so cuba kita study dulu sekejap this equation. Okay, kita study sekejap equation ni. Okay, so basically, cuba kita tengok yang pertama ni. H2O and H3O plus. So basically water ni, okay, dia dissociate jadi H plus and OH minus ion. Okay, so ini dia punya equation ionization of water. Maksudnya water ni dia akan bercerai jadi ion. So ion dia adalah H3O plus ataupun H plus and also OH minus. Okay, so nanti kita akan belajar KW ni sebenarnya. KW ni adalah equilibrium constant for water. So formula dia, ingat tak kita belajar Kc, Kp kan? So kalau liquid, kita tak akan tulis expression dia. Kita ignore. So dia punya formula Kw equals to concentration of H product lah. H3O plus and OH minus. And the value is constant. Okay, value dia awak boleh cari dekat sini. Okay. So, yeah. Okay, for pure water, okay, untuk air yang pure, kandungan asid dengan base sama. Kalau kandungan asid dengan base tak sama dalam air tu, macam mana awak nak minum kan? Kita tahu water is neutral. So, bila neutral tu maksudnya asid dengan kandungan base tu sama. Okay, now, yang ni tak ada apa, yang ni tinggalkan kosong. Step yang ketiga, kita bawa equation ini tadi, kita letak negative log on both side. Okay, cuba tengok negative log on both side. Okay, yang ni pula, madam kembangkan dia. Okay, jadi log H plus dengan negative log OH minus equals to this one. When you calculate, you akan dapat 14. Okay, so negative log H plus ni tak ke sama dengan pH? Ingat balik equation pH tadi, pH adalah negative log H plus. So basically this is pH. Negative log OH minus adalah POH. So basically, the relationship between pH and POH adalah equals to 14. So tolong hafal equation ini because this is very important for our calculation next. Okay, now kita move on to the calculation part. Now, kita nak kira pH untuk strong acid. So, soalan tanya, what is the pH for 0.05 molar sulfuric acid? Okay, kita tahu sulfuric acid is a strong acid. So, first you write down the formula pH equals to negative log H plus. So, next substitute the concentration. Masuk je. Yang ni very direct. You tekan calculator negative log 0.05. You should get pH equals to 1.3. So, ingat balik pH meter kita kan. pH kita ada 1, 14, 7. Kita tak ada pH equal to 0. So, 1.3 maksudnya dekat sinilah kot kan. Okay, kalau 1.3, so maksudnya dia dalam range acid. This is acid. This is range untuk base. So, makin ke kiri, dia makin menuju ke arah base. Okay, next. What is the pH? What is the pH of aqueous solution of 1000 cm3 containing 0.025 NaO? Okay, guys, for this one, dia nak cari pH tapi dia bagi NaO. NaO adalah base. pH sebenarnya untuk acid. So yang ni dia punya soalan is not straightforward. So you are given the mass of the NaO. So you kena cari dulu dia punya mol. Okay, so sorry, molar mass dia. Molar mass NaO, sodium 23, this one 16, 1. Okay guys, cuba kira sekejap. What is the mole for NaO? You should get 4.1667 exponent negative 4 mole. Okay, good. Okay, cari dulu mol. Okay, dia bagi volume 1000 cm3, so itu bersamaan dengan 1 liter. Okay, once kita dah dapat mol, kita dah dapat the concentration, now we find out dia punya, kita dapat volume, so kita boleh cari dia punya concentration. So, divide by 1. So, basically, concentration dia sama lah, which is 4.1667 exponent negative 4 molar. Kalau kita tengok daripada equation, dia punya concentration ni, maksudnya concentration NaO ni rendah. So, kita tahu sodium hydroxide, okay, sodium hydroxide is a strong base. So, ingat balik definition untuk strong base, dia dissociate completely jadi ion. Okay, so if we have the concentration of NaO tadi 4.1667 exponent negative 4, so untuk OH pun sama, which is 4.1667 exponent negative 4. So the concentration here is the same lah. Don't forget the unit. Okay, sampai situ. Once kita dah dapat OH, kita gunakan formula POH, okay, negative log OH minus. Okay guys, so cuba negative log OH minus tadi berapa? 4.1667 exponent negative 4. Okay, cuba tekan the calculator. Dapat berapa? Okay, you should get POH equals to, ambil dua saja tempat perpuluhan. pH kita tidak kira sampai macam contoh 4, 2 pun dah cukup. Okay, so basically POH dia adalah 3.38. Tapi soalan nak pH kan? Yang kita cari tadi POH. So use the connection between pH and POH. So 14 minus 3.38. So dapat berapa? You should get 10.62. Okay, pH jangan lupa mana ada unit. Okay, so basically that's the pH for NaO. So logik lah kalau kita tengok skala dekat sini, berapa tadi? 10.62 kan? Sekitar sini, for example. So betul lah sebab sodium hydroxide adalah base. So dia sepatutnya berada in the range between 7 and 14. Okay, so very simple. Okay guys. Cuba buat example 14. Example 14. Example 2. Okay, calculate the pH for the following solution. So for A, you sepatutnya dapat 2.70. For B, you should get 7.30. For C, you should get 11.70. So if you got all of them correct, good job guys. Okay, next 2A. Calculate concentration of H plus and OH minus with a pH of 2.5. Okay, so for A, cuba kira guys concentration of H plus. You should get 3.1623 exponent negative 3. Okay. Untuk kandungan OH minus, you sepatutnya dapat benda yang sama. Okay. For B, cuba cari sekejap the concentration of H plus. You should get 5.0115 exponent negative 12 molar. Concentration of OH minus, you should get 1.9953 exponent negative 3 molar. Okay, guys, do the next one. The last one. How many grams of NaO is needed to prepare 250 milliliter solution with pH of 12.0? Okay guys, cuba kira sekejap. You should get ambil 2 tempat perpuluhan. So 398 0.11 gram. Okay guys, good job guys. Okay, so I think that's all. So see you in the next lesson. Okay, thank you. Assalamualaikum.